Today we're going to be talking about the distributive property. So the distributive property is something we use in math in order to help us write things in a little bit of an easier way. So when I talk about mathematicians are lazy, we're always looking for the shortcut, the distributive property is one of those shortcuts. So in your notes you have an example. It says a charity sells pots of flowers for $10 each to raise money. 8 people pay with a bill, so meaning with cash, and 5 people pay with a check. So we can write this in two different ways. So if I want to know how much money I have altogether, I can write it, and the way that we probably would have done it up until this point is, well, I have $10 times the 8 people that paid with cash, plus I have $10 times the 5 people that paid with a check, and that's going to equal my total. So as I do this, I would do some order of operations. So I do my multiplication first. So I'd have 80 plus 50. I'll do it downwards. And that will give me $130 altogether. Now, another way that I can write that is to say, well, I had $10 times 8 people who paid with cash plus the 5 people who paid with checks. So if we go through and we do this math here, I have to do my brackets first. 8 plus 5 is 13, so 10 times 13 is $130. So no matter which way I structure it, I'm going to get the same answer. So when I write this is actually what the distributive property looks like. So basically what happens, and if we were to change this into something more generic, so where I didn't have numbers in there, but I had letters instead, I could say that I have $10 times the number of bills I receive plus the number of checks. And what actually happens is this 10 gets multiplied both by the bills and by the checks to get our final answer. So the second sort of example there talks about selling tickets for $20 each. So they have bills and they have checks again. And so we don't know how many they have of each bill and check. So there we're going to have 20, because that's how much you got no matter what, times the bills plus the checks, which when I multiply that in, so this is us distributing it into or handing it out to each of the pieces inside of those brackets. So I would get 20B plus 20C. So what we're going to do is we're going to do a few examples here that show you how we use the distributive property in order to write things and how to solve different types of situations. So I'm going to get rid of this and we are going to go into the first example. So for example 1, it says use the distributive property to write each expression as a sum of terms. So remember that word sum means the answer to an addition question. So when I have example 1, I have A, which is 7, bracket C plus 2, and B, which is 42, bracket A plus B. So what I'm going to do with these, and I highly encourage you to draw these arrows because it keeps you a little bit more organized, and eventually as you get older, you'll have more than just 2 things in here. You might have more, 4 or 5 going on. So it just kind of helps you remember what all you've done. So I'm going to take this 7 and I'm going to multiply it by the C. So 7 times C just gives me 7C. and by the 2. So 7 times 2 gives me 14. So all I'm doing is I'm taking whatever's outside the brackets and I'm multiplying it by each piece inside the brackets. So 42 times A is 42A, 42 times B, 42B. Just like that. Now, when we do this, we call this, in math, oftentimes the word that we are given in the question is expand. So when we are asked to expand, this is what we are being asked to do, is multiply that outside number into those brackets. So example number 2 has those directions of expand. The first time we see that. And again, it has 2 examples there. So I'm going to write them down before we get started. That's an A. So when I look at these examples, the difference is now I have negative numbers going on. But we know how to work with negative numbers. We still follow those multiplication rules. And so all that happens is we have to take that extra moment to think about what is the sign going to be of each of my terms now. So negative 3 times x is going to give me negative 3x. Negative 3 times 5. Now, this is where I often pause. I will do the number. So 3 times 5 is 15. And a negative times a positive gives me a negative. So whatever sign is going to go with my multiplication is going to go in the middle. So negative 3 times positive 5 is negative 15. And we use that as the adding or subtracting sign. So when I go into the second one, negative 4 times negative 5, that's going to give me 20. Negative times negative is a positive, so if I want, I can write that positive there. That's okay, or I don't have to. Negative 4 times positive A, so 4 times A is 4A. Negative times a positive is a negative. Now we have another example here before you guys have some questions. So we are going to do example number 3. Again, it says expand. And we got 2 examples here. So what we're going to do is we're going to do 6 times x is 6x. 6 times 3 is 18. A positive times a negative is a negative. This last one, 5 times 8 gives me 40. 5 times c gives me 5c. A positive times a negative gives me a negative. Now, in your notes, it actually breaks it up and has you rewrite the equation a little bit. I don't like doing it that. I think that you guys are all good enough with your signs that you guys don't have to do it that way. I encourage you to take a look at it, though, just to see what's going on, because it is a little bit different. You guys have some practice questions there. Oh, there's one more example. Oh, no, there's not. Sorry, I flipped too far. You guys have some practice questions there. Give them a try. Let me know if you have any issues, and I'll be happy to help you out.